Good evening. Welcome back to the lab. I'm going to do my first Eico video here on the probes. I pretty much got all of them. One of them I have not been able to find. Actually, there's two. So we're going to start at the basics. This is a direct probe used for oscilloscopes back in the 40s and 50s. Let me get the schematic up here. So you basically have your input straight into the scope. There's no capacitive adjustment, definitely not meant for high frequencies. So that's the first one. I have put BNC connectors on the ends of these, and I've run them with a 50 ohm coax. And then on the scope, most of those had binding posts. I have like little L-shaped adapters for BNC connectors, and I use this one with a female BNC jack on it. So when it's in operation, you hook your BNC and plug this into the two banana jack adapters. Now, on these you have the tab on the side, and that's usually the ground. But if you use these, definitely want to check it with your ohm meter. Okay, so that's the direct probe. Next up we have the low capacity probe, which is also used for the oscilloscopes, and I don't think most of those like 425s or 460s went much beyond 5 megahertz back then. And this is basically a variable cap with an inline resistor, and it has the little adjustment hole here on the side. And most of these came as a kit that you could build. I'll show you on this one. The end of it is threaded, and you can undo the plastic top, and out slides the PC board. And it's basically point-to-point wiring. Now on this one you just mainly got to make sure that your capacitor lines up with your adjustment hole. And that's it. Got a BNC on that one too. Next up, where'd it go? It's the green one. This is the demodulator probe. This one is also for oscilloscopes. Let's get the schematic for this one over here. So this one has your 1N 48 or 34 input capacitor and load resistors. This is mainly for impedance matching. And so this you would use like troubleshooting a shortwave receiver or something. Strips the RF off, passes the audio through. Also with a BNC connector and a 50 ohm cable. Next, now these are going to be interesting. This is the RF probe. Same design. I think these are roughly 6 inches long. Schematic for this is your basic RF probe. Now this one's not numbered, but there's an RF11, which is this one, and an RF25, which the only difference is the input resistance. I believe these were designed to go with the voltmeters, vacuum tube voltmeters. So this one happens to have the microphone connector on it. A lot of my vacuum tube Eicos have a 1/4 inch audio jack plug on it. I might want to switch this back. I'll think about that. Anyway, I'll open this one and show you what the guts on this look like. They're really easy to service. So there's your input capacitor, your diode, resistor, and the shielding is always connected to the output spring or insulating spring, whatever you want to call it. So if you had bought these as a kit, I'm thinking you'd probably have one of these assembled in less than 30 minutes. As far as collecting these, my problem has been finding ones of these with decent paint still on them. Most of them look like the demodulator probe or the direct probe, very beat up, but that means they got used. So the next one, and remember this one has two different input resistances, and all you have to do is change that one resistor from a 4.7 to a 20 meg, depending on your input of your voltmeter. And in the instruction manual for this probe, I actually have a chart of different resistances for different voltmeters that were available at the time. So next up, oh wait, let's back up here. This is a RF 75 and 76 probe, which is pretty much the same. The only difference I was able to see is the connections you have. So this will be one for like the vacuum tube voltmeter that most of these Eicos had with the blue face. And this one would be pin connectors. Typical input, almost like a demodulator probe. These are more designed for measuring voltages on the voltmeter though. So next up is the peak to peak. It took me a while to find this one. Still in the original package. Now these were designed for work with, I think, only two types of voltmeters with Eico. I want to say the 221 and the 114. Anyway, you can tell by the gauge will have a peak to peak in a center setting, and you can dial it in with the knobs for 0. Now this also had two different resistors in it. The peak to peak 11, which is what this is for a 10 mega ohm input, and this one is the peak to peak 25, which had a 25 mega ohm input. Other than that, they're virtually identical. Okay, now this one, I could not find a schematic for it, so I'm just going to use this is the Eico Uniprobe. And I'll pull, where'd that one go? Pull this one out. Has a little notch cut in the end, the red dot. So if you're on DC, I believe that bypasses the resistor. And basically this is a 100K or a 1 meg, I believe. And when you rotate this, it shorts the two terminals out and cuts the RF, bypasses that resistor. And it does have a capacitor in line. On the other side, you can just rotate that to AC or ohms. Now this is also designed for the ohm meters, and this also has a microphone plug. So finding one of these in good condition is pretty hard. I've found tons of broken ones though. Okay, now we'll get down to the high voltage probes. There's differences. Okay, put that away. First one is, this is the HVP1. And the difference you can tell is this one has 3 fins on it. Yeah, basically the same as the design. You can see the resistor in there, and it comes with a chart. So I'm seeing this how I use Eicos. Okay, so the RCAs, wait a minute, this is not for this one. Okay, this is for the Eicos. Now the first one, which is this one, HVP1, has a 470 meg. I kind of take their word for it because I don't have a mega ohm meter yet. but that's what's stamped on it. And this is designed for the 10 mega ohm input. Okay, the next one up.
This was the first sign that something was wrong. But after double check.
This is the HVP2. Only 2 fins. These are supposed to design for keep the RF or high voltage jumping across to your hand. And as you can see, the regular cables, this is one for the voltmeter. They were, gosh, at least a 1/4 inch thick. And I got thinking about this. If you're hooking this into your voltmeter, most of the voltage, if you're measuring, say, 10,000 volts down here, most of that voltage is dropped before it even gets to this cord. This one has a 740 in it also. A little bit bent, so I'm wondering what they did to overheat this thing. I put a new cord on it. This is good to 6,000 volts in a new 1/4 inch plug. Like I said, most of the voltage is dissipated or gone, divided down to 1,000 volts or less by this end of the resistor. Okay, now I just ordered this one and I was kind of surprised. It's also an HVP2, 2 fins, but when I took the resistor out, this had the 1090 mega ohm resistor in it, which is designed for the 25 mega ohm input resistance. Almost all my yellow. So next up, we've got these high voltage probes. This is the HVP1, designated by the 3 pins, and the front is clear acrylic. Be looking like this. This one has the 740 meg resistor. I'm just going to take their word for it because I don't have any way of measuring that. Comes with the 1/4 inch plug for the vacuum tube voltmeters and a 1/4 inch cord, which is, this isn't too bad. Most of them are cracked pretty bad. Anyway, they came with a chart. So this one with the 470 or 740 mega ohm resistor is set up to read up to, I think, 30,000 volts on the 1,000 volt scale. So we look over here on the Eico, it meets these voltmeters, and depending on your resistance, this is the 740, it'll go up to 30,000 on the 1,000 volt scale. So it's like a 30 times multiplier. Okay, so next I got this one, which is the HVP2. Similar in design, except it only has 2 flanges, and I guess the idea was to reduce the risk of high voltage flashover. My understanding of electronics is if you put 10,000 volts in here and you have your dropping resistor in here, by the time it gets to this point you're down to less than 1,000 volts, and I've personally never seen that much arc more than maybe 1/4 of an inch. So this has been replaced with some high voltage test lead wire. This is good for 6,000 volts, it says. 1/4 inch plug for the vacuum tube voltmeters. And so I just recently bought this one. Much nicer shape, still got the 2 fins, but this one has a 1090 mega ohm in it. Again, taking their word for it because I don't have a mega ohm meter. So I'm going down here to the page, and you can see the 1090 works on these 2 voltmeters, and it's on the 500 or the 150 scale. You can read up to 50,000 volts with that sucker. Impressive. So now that I'm looking at this one here is only good for the 214 and the 221 on the 1,000 volt scale, 300,000 maximum reading. Most TVs I've worked on, I don't think I've ever got much over 25,000 volts out of the flyback transformer, but could be something out there. All right, so we'll put that one away. Next up is this signal tracer probe. Yeah, very clever. This is the PS1. Has a momentary button. Now this, I don't know if you can see this, there's a notch cut in this, so you would push it in and then cock it sideways to hold it on while you're signal tracing through the radio. Now this generates a ton of harmonics, and it's supposed to be inductively coupled. And it takes some really weird batteries. To shut this off, you just pop the pin back out and it's off. This took some batteries that are called N somethings. Let's see if I can open this. Ah, well, no batteries in that one. Anyway, the whole circuit's in here. One transistor, a transformer, 2 batteries, and a capacitor for the output. So they also made a second one called this is the PS1. They made a PSI-2, which had a headphone jack here. I'm going to build one because I haven't been able to find one. And then on the front it had different attachments for like different frequencies you're measuring or injecting. I was thinking I'm going to put a 1/8 inch headphone jack here, a banana jack sticking out the front, or a plug, and then you can attach whatever adapters on the front. So if anybody sees this video and has run across a PS-2 that is for sale, let me know. I would be interested in owning it. Alrighty. Next up, we're getting into the later years. Schematics kind of screwed on this one. Anyway, this is the DLP6 logic probe. You got your power on and off, and I believe this is supposed to hook to 5 volts. It says so in the schematic. But this is for, like, gosh, back then I think it was TTL circuits. You get your high, your low, and your pulsing. Again, this all fits on a really small PC board in here, and I believe there's 2 logic chips. NAND gates or AND gates, one of those 2. Yeah, I'm not going to mess it. Anyway, you can still find these occasionally, and if you have one, I do have the schematics and the assembly and owner's manual for this. Give me a holler if you need it. And that's about it for the probes. There is one other probe I have not found. It's a, where'd it go? It's a low capacity probe, but it's set up, it's a different style than this. It's set up for the higher frequency scopes, like a 5 to 50 megs. Different design on the probe with a 10-to-1 switch on it, and it's called a PLC-2. Also have not been able to find one of those. Oh yeah, before I go, I do not have an active RF probe. So I came up with this idea. Let's see what I find, what I did with this stuff. So I went to the Home Depot and I got a length of copper pipe. Cut these to fit about the same length. You get the caps. These are typically 1/2 inch. You know, fits on there. Drill your hole out. Put your tension spring, whatever you call that thing, on there. The front, I just ordered. I went down to my plastics guy to get a. This would be like a 5/8 head. He didn't have any. So I went on eBay and found some. It wasn't cheap, but I got enough to do quite a few probes. It's not going to be threaded like this one. What I intended to do was, you know, just cut this to fit inside, maybe glue it. I'll leave this end open with the spring and just load the circuit board through the middle, put the cap on. So, shielded, should be good to go. Anyway, I'll see you in the next video. If you got any questions or comments, just leave them down below. And if you need schematics or stuff like that, give me a holler. I got a ton of Eico information, even some rare stuff that's usually not available. So enjoy. This is my collection hobby, my Eicos. I'll be going through my machines one at a time, starting with well, I might do the true ohm voltmeters first, and then we'll go into the 100s, signal tracers, signal injectors, and just go from there. Have a good day. So last but not least is the HVP5. Now this one is self-contained. I think all it comes out is a ground wire. See if I can get this open. There we go. So this, you don't need a voltmeter with. It has one built in. Clip to ground, high voltage on the end, and it measures from 0 to 30 volts. First one of these I bought didn't have the voltmeter in it, but it did have the resistor, so I had to go search for another one. So in order to keep all these somewhat in shape, I built this rack. These are like cable tie clips, 1/2 inch in diameter. Got them at Home Depot. Since I needed a bunch, I bought a whole jar. And so when I store these are hanging on the wall like so. And I'll put my probe in and it just snaps right into place. Does not get damaged and it's held securely. I get these all set in here and back up so you can see the whole shop. These are Panoma test lead racks. Work really good. So I think I'm gonna need, I'm gonna drill another hole over here for my other HV2. Anyway, so there's some ideas and suggestions and whatnot. Make your own. Thanks. Have a good day.